Hello, good morning. Happy to see you all of you here. My name is Marian, and I love to integrate. And it got so far that I started writing a book about designing and implementing APIs. And writing a book takes a lot of time and effort and energy. And I sometimes have to ask myself, oh my, why have I actually got into this? And the answer hopefully will be in this talk. It's because in my experience, in my career, I've experienced a lot of projects where APIs and integrations in general were neglected up to the point that it was too late, because once an API is in use, it's pretty hard to change. And yeah, by the way, here is a QR code and link to a page where you can learn more about that book project. And you can also get some free stuff there, some samples of the book, and also a lot of other related stuff. And of course, if you forget to ask some question here during the session, you can talk to me anytime you want, and we can discuss some interesting things. But back to my talk. Basically, maybe I can ask you, how many of you have experienced a serious problem that was caused by an API that either you personally or your team was developing? Okay, we have some brave people here. And how many of you have experienced serious problems caused by an API that was a third party, that was developed by somebody else and you had to work with it? Yes, I know it. It's always the other ones who make the mistakes, right? I know you're all smart guys here. But when writing my book, I collected a few small things that I will present here, and hopefully in some way through the ether and the universe, this information also gets to those third parties that make all those mistakes. But before I go to the first slide, I want to do a little psychological experiment on you. And I will say something, and you should try to remember what thoughts, what images it triggers in your mind. And the thing I want to say is, where is it? I lost the presentation. Sorry. Okay, let's do it again. Okay, here it is. So the word I want to say is API, of course. Got it? And now, how many of you, when I said the word API, started imagining some kind of a REST API? Okay. Maybe it's not more than half, but still I think it kind of proves my hypothesis that REST APIs are quite popular. And why so? Basically because the World Wide Web is everywhere, and the REST APIs have become some kind of a ubiquitous language that everybody in the IT industry has to understand and support in some way. And also we had an attempt to define standards for web services, the so-called SOAP web services, but unfortunately they were missing the KISS principle, which is keep it simple, stupid, and that's why probably REST is way more popular now. And but you know, just the fact that you can use it for so many things, and you can even write a book about it, like me, doesn't mean that you should use it for everything, right? So when a programmer needs to what the program usually wants to do is just call a method or a procedure, and the only caveat is that that procedure is sitting in some different process on a different machine. So the programmer doesn't want to care about protocols and resources and headers. So if actually the clients, the number of clients is limited, and you have the control that you can assume that the client will use your favorite technology, then of course you can use an RPC style of API. For example, if you use gRPC, it's great, and you also get the bonus of transferring the data over the wire using an efficient binary encoding. So that might be the thing for you. Another consideration is that many times we use APIs to connect microservices or just any applications within a company, within an organization. And the number of PCs that we need to connect is so large that we want to decouple those parts, and using messaging infrastructure, messaging brokers like Kafka or some cloud-based queuing service is a great way to do that. So you can be event-based, and of course you need to keep in mind that messaging is inherently asynchronous, and asynchronous processing and communication is more complex to think about than synchronous one. Okay, and another popular alternative to REST is GraphQL, which gives you a query language on your API. So it's good if you need to, if you don't actually know what combinations of entities and their attributes you will need to work with. But here I would be a little bit cautious, because the fact that you need query language on your API might indicate maybe not weakness of REST, because with REST you also can have query parameters, and you can use very flexible data structures if you need. But it maybe is an indication of a lack of requirements analysis, because you don't really know what you will need to do with that API. And of course also the fact that you have the flexible query language on your API will probably lead to your clients doing quite complex logic with it, and part of that logic might be duplicated if you have multiple clients, and maybe the better solution would be to put that shared logic on the server. Okay, But let's assume you do want to use REST APIs. If you make this decision, I think you should do it properly. You should understand the basics, the principles, and not just get inspired or just copy-paste some nice-looking example. Here we have a notorious example, which is the Spec Store API by Swagger. And here we can see we have a put method, we have a payload, and that payload contains an ID. And now I'm asking why that ID is in the payload. Well, probably because there's also a post endpoint, and that post endpoint needs to return an ID of a newly created pet. So, and we programmers love to reuse stuff, so why not use the same data structure also for put? Well, in APIs, sometimes reuse can have not so good consequences. And now the key question here is, what is actually a URL? So what is that thing up next to the put method? URL is something that every one of us uses every day, but we forget what it really means. It's a uniform resource locator, and as such, it's one of the two possible types of a URI, which is a uniform resource identifier. So besides just telling the machine where and how it should go to access the resource you want to access, it should also identify the resource uniquely. So what we have here, we are putting pets. And imagine you will probably need to also get some pets. And here you would with a high probability also include the ID in the URL, right? So now we have an inconsistency. Or, of course, you can also have a get endpoint that gets all the pets, but it would be very unusual to have a put endpoint that overrides all the pets in one request. That could be even dangerous. So, in summary, use the URL for what it is designed for, and try to understand the basics of REST. Now, when we design our REST endpoints, we should name them somehow. Actually, the REST itself doesn't prescribe any naming of the resources, but even in programming, you could rename all your variables to A1, A2, A3, etc., basically obfuscating the code, and the program would work as before, but maintaining it would be a nightmare, right? And I think the same goes for APIs. Therefore, we have some best practices for naming the resources and for some hierarchical structures of the resources. And here, one of the best practices is that we should use nouns to name our resources. Why is it so? Because the verb is already in the method. So, sentence with two verbs doesn't really make sense. So sometimes you just need a very simple change. So instead of approve an order, you can name it that we are putting an approval to the order, and then we also can define a respective get endpoint, which could check if there is an approval for the order or what some data about it. Also, we can generalize and put approval and cancellation in one endpoint and name it for example, status. And the advantage of the English language is that many words can be both verb or a noun. So to order is the same as actually an order. So that's a way to name your resources nicely. And it may sound like I'm being religious about these guidelines and recommendations, and I wouldn't like for you to take this away from it. I really like to break the rules when it brings you something. So try to be restful, as restful as possible, while it doesn't cost you too much and it can bring you a lot. And a great example for this is this Richardson maturity model that defines some levels of restfulness, basically. And you don't have to fulfill all those requirements. One requirement that is very rarely actually fulfilled with real-world APIs is the hypertext as the engine of application state, or HATEOS. In practice, instead of using hypermedia, we often reach to the Open API standard to tell the clients what they should expect from the API. But how do we get to this Open API specification? Well, for APIs we have two basic approaches. One is called code first, and the other one is called specification first. And many people consider them like almost equal, and so that means you're free to choose which one you take. But in my opinion, it's not the case. Let's see. Here we have an example of a Java code. Yeah, it's also an API, but that will come later. What we can see is that some members are private, some members are public. Why is it so? Because Java is an object-oriented language, and in object-oriented languages we encapsulate. So we only make public those parts that we really want to be accessed from outside, and the rest is hidden. And why we do it? Because this gives us the freedom to change the private parts without affecting the outside of our class. And if we do this for APIs that are within one program, I think it's even more important for APIs that can be accessed from the whole world. So that's why I believe that actually the code first approach is quick, because it lets you develop the first version of your API very quickly, but at the same time it's dirty, because it leads to the situation that your API specification is mixed with your implementation. Here we can see that we have some dependency injection, we have some service invocations, which are definitely implementation details, and the Open API specification, if we want to generate it from the code, is defined. It is basically spread across our code in different places. It is some of it is generated from these annotations. Some of it is inferred from the data structures that we use for our endpoint requests and responses. And usually when we want to have really a complete open API document, we also need to provide some metadata that's totally disconnected from our Java code, and then the question is, if you already, and of course if you make any change to your code, you should think about what it will make with the generated open API, how will it affect it or not. So I think it's actually, in the long run, it's easier to learn that open API, maintain it directly, and do it the vice versa. So generate the API specific code from that open API specification. And yeah, of course, you need to generate it on every build so that it's fresh and in sync. And if you're using a strongly typed language like Java, then in case something gets out of sync, you will be informed immediately, and you will need to fix it. That brings me to another topic, and that's frameworks that we use to implement our APIs. It has a long we have a long history of, and it doesn't stop. It's still ongoing. We back in the day with Java, we had Java 2 Enterprise Edition. Then it was generalized to just Java Enterprise Edition. Then it was a very successful actually. That basically is probably the reason why we still have Java as an important player here, because that let Java get at home on the server side. But at the same time, the early versions of Java EE were not easy to use. That's why we got the Spring framework, which provided some useful abstractions on top of Java EE. Meanwhile, Jakarta EE or Java EE got better. Now it's named Jakarta EE. But also, some people didn't like that they need to deploy their applications to an application server. So Spring Boot was born. Then later we started putting our applications in containers and going serverless maybe, and we realized that the time that the application takes to start matters, and if it's 20 seconds, it's probably too long. Then new frameworks came that tried to address this problem, like for example Quarkus, that radically decreased the startup time and also memory footprint. So how do we deal with this ever-changing world when we start implementing our API with some framework? You start from a Hello World API, because in every programming language you have a Hello World program that prints Hello World into the console, and with almost every application development framework we have a Hello World API that shows you how easy it is to create an API that returns Hello World. But as the application grows and you have multiple applications based on the same tech stack, then very quickly you get locked into that framework. And now what can you do? How to innovate or not miss out on the opportunities of the new frameworks? I think one thing that you should bear in mind is you shouldn't jump to something just because it's new and cool. You should also pay attention to the not so cool things that are called standards. Actually, Java EE is a standard, or Jakarta EE is a standard. And we have some new standard called microprofile, and I think it's really something that you should be interested in, because it joins the legacy of Java EE with these new frameworks like Quarkus or Helidon. So that's one way to stick to the standards of the application frameworks. And also, as I told in on the previous slide, you can always try to use OpenAPI to generate your code, and that way you can switch to some new version of a framework or to a different framework without going through all the code and checking what annotations need to be changed. So that's about this. And another thing also related to frameworks is that the fact that it's so easy to expose something as an API can be a trap that means that you expose too much. So you really should think about what you're exposing, what you actually need to expose on your API, what you expect from that API. Here we have an example where we expose using a controller and database structure. Basically, we expose an entity which is quick and nice, or easy, from the start, but you can get burned by this, because for example, here we can see JSON ignore. That's there because we needed to prevent an infinite loop when deserializing this one-to-many relationship to JSON. Another thing, you might want to add a field like this description to the entity, and on some environment you forget to migrate your database properly, so the database table is missing this field, and some nasty things can also happen to your error handling, actually, because then the exception, this SQL exception, is not caught within your service layer. It leaks into your JSON deserialization, actually, because this one-to-many relationship has a lazy loading, and that happens when the framework tries to deserialize that data into JSON. So don't do this. Use DTOs. That's the thing that's designed for separating the layers. And one thing that's also interesting is that thinking about what really needs to be exposed in API is something, a rare case where actually security and performance go hand in hand, because limiting what you expose is of course good for security and also for performance, because imagine that we had not just one-to-many relationship, but multiple of them. I've seen such situation, and if you just decide to copy or mirror, even if you use DTOs, many people just copy over all the attributes to the DTO, and then of course it's actually impossible to write an SQL statement that gets you all the one-to-many relationships in one select statement efficiently. So, and of course, once it's in the API, it's hard to change again. Then, I mentioned generating code from OpenAPI, which is of course good. And you may think, okay, when I'm already generating the code on the server, I can use it and generate also a client library for my clients in the same spot. It's quite common that we use APIs to decouple things, and this way you are coupling your client to the server again, because you are forcing the client to use the same library, probably the same versions of transitive dependencies, and of course I'm not even saying that some clients might want to use a completely different language for their implementation. So it is better to share the OpenAPI specification. And even if you do that, there might be some parts that you might want to reuse across multiple APIs. Again, beware of the possible coupling, and if you do that, you should make sure that the reuse part is really stable. One very frequent example is that you need some structure to report failures, errors from your APIs. So there is an RFC, a standard that is like across the whole industry. So whenever there is a standard that you can use it and don't reinvent the wheel. And talking of RFCs, the one RFC that you definitely need to know is the HTTP. So you need to know how it works and why it works that way. So, and status codes are really a basic part of the HTTP. So if you return an OK status when there's actually an error, what can happen? The client may ignore your payload and just think, okay, everything's done, and I can throw away the data that I've just sent, and you get a data loss. Another example is returning 500 when actually there's something wrong that the client has sent. In that case, the client might decide to retry like crazy, overwhelming your network and your service without a chance of success. So that's again something that should be properly addressed. Another thing is the data structure that's the most popular right now with REST APIs is JSON. Unlike XML, JSON allows you to use an array on the top level, and of course if you're returning a collection, that's the default way to deserialize it. Here actually what I'm suggesting is a little bit of an over engineering, but again it's something that's pretty cheap, and it can save you some problems in the future, because with collections it's quite probable that the number of items will be big, and you will need to introduce pagination, or you can need to introduce some other metadata with that list. And if you wrap the array in an object, then you will have a place where you can put these things in a backwards compatible way. Talking about backwards compatibility, it's inevitable that something in your API will need to change, but you should be prepared for it from the very start. You should have a clarity in what actually is a breaking change and what is a non-breaking change, because it's not always by the book. For example, the typical example is that you add some new field, optional field, and the client should ignore it. But are you really sure they do it? Maybe there are some clients that are so strict, and if they see some field that they don't know, it will be an error for them. Another thing is bug, fixing a bug. If you know semantic versioning, the last element is the patch version, so that's the one that you will increment. But there might be some clients that have already developed a workaround for your bug, and now when you fix the bug, it's actually a breaking change for them. Another thing is the opposite. If you, for example, have a full stack team and you develop both front end and back end that are connected via an API, then actually what should be a breaking change might not be a breaking change for you, because if you are able to coordinate the deployments of the back end and front end, then you don't have to pay the price of maintaining multiple versions and all the stuff with versioning. Okay, and if you want to do versioning, there are various ways to do it. So many guidelines tell you just put v1/v1 in your endpoint and you're fine. You're prepared for versioning. It's not that simple. If you need to change something in a breaking way, usually you just need it in one or a few endpoints. You don't need it for all. And now the question is, should I copy the whole tree of my resource hierarchy to /v2? If I don't want to do it, will the client understand that some resources are still in version 1 and some are in version 2? What if they try to use, for example, relative URL paths? And okay, then you can say, I don't want to put it in the beginning of the path, but where should I put it? Is it okay if I put it after the ID? Another option is to use headers for versioning. That's less intrusive for your APIs. You can use, for example, content type, which is very RESTful. And of course, you always win when you can make your change backwards compatible and you don't need to create a new version. But actually I forgot to tell, if you're the copying of the whole resource hierarchy to a new version, that means also that every time you make a change you get a new version number at the beginning, so it can grow quite quickly, and of course maintaining like 7 different versions in production is not fun. So there's always some advantage and disadvantage, but if you want to go that avoiding breaking change way, there's also a limit to it. Yeah, this is a very nice piece of data, right? Why does this happen? Usually it can be connected to the fact that some team has some problems with creating new versions of a schema. So they decide to embed a schema inside a schema, and then everybody's happy because the schema is always backwards compatible. Yeah, of course, the problem is that this embedded schema is usually not documented anywhere. It can even break some syntax rules. For example, here this encoding is probably lying to you. And of course, the code that needs to deal with such data structures is it needs to be dynamic as well. Yeah, another option to basically bypass the schema is to use a structure known as a key list of key value pairs. Yeah, that's or a generic JSON object without specifying its properties. That works too, but yeah, that's cheating, because then on each client and probably also the server needs to have some kind of a generic code that works with those flexible data structures. And if something changes, you might not notice that something is broken because your schema is still backwards compatible. So in many times it may be actually better to have explicit data structure, even if then you risk that there will be breaking changes, because of course, even again, if you generate code, or if you have just code in a strongly typed language, then if something changes and it doesn't match, you get early warning, not bugs in production. And also, it's probably also a feedback to your business, because if you need to use such generic structures, it again is probably an indication that there's a lack in business requirement specification or analysis. And now when there's a breaking change, it costs, it requires some work, and then basically that can make your business people understand that basically we all know that failing to plan is a planning to fail. So it's better to know what you really want. And this is the last slide actually. We all want a well-tested software, and we know the testing pyramid, which says the unit tests are the base. They are they should cover everything, and many times we define some minimum test coverage ratio for our projects. And what does it cost? The developers write tests for everything, including API code, and these tests usually do not really test anything, because for APIs the most common errors lie in configuration, deserialization, serialization, authentication, things that the unit tests usually abstract away from. So it's probably better to exclude the API specific code from your test coverage requirements, and you should use tools that really spin up the real thing, the real application, and fire real, for example, HTTP requests to it. There are tools for it, like test containers and rest assured, to declaratively write such tests. So that could help you to get a really tested software. And that's the end. So now it's time for your questions. Okay, so the question is, what is the right way to return an error? I mentioned it a little bit. There's an RFC actually for it, that for the structure, so that you can provide all the details the client may need. Of course, for security reasons, you probably shouldn't expose everything, but only the safe stuff. And of course, you should use the proper HTTP status codes, which are defined in the HTTP RFC. So if it's authentication error 401 or 403, if it's something that's not found 404, if it's some other problem, you can even if it's 400 for everything, it's still better than 500, because as I've shown you, it will mislead your clients. So yeah, understand what you have and use it. Don't go against it. That was actually one of the problems of SOAP, that it used HTTP just as a tunnel where everything was hidden from the infrastructure, also for like caches or whatever can be on the way between you and the client. So use the standards the right way.
You showed us the problem plus JSON response for errors. How do you handle that if you for multiple endpoints, for example, and especially in connection with Open API? Like, do you specify the error object for every endpoint in the Open API specification, or do you have something like a generic response that has a map, string value pairs and something, or how do you do that? Because maybe you could show the slide again, then everyone knows what I'm talking. Like for example here, this one is now an error very specific to the, I don't know, purchase endpoint or something. And for a different endpoint, it would maybe the type and title and detail would be there, but everything else would look different. So how do you manage that?
I think that's already some kind of have you heard it? So yeah, the question is how do I handle this for different endpoints that might need different values here? I think this is more or less a mapping problem, that you need to map the values that make sense to this structure that can be reusable. Of course, you mean like reusing some parts of the mapping, or?
Well, if you have the Open API specification, right? Mm-hmm. You have you say, okay, if my endpoint returns a 200, I'm returning you an object of this shape. Mm-hmm. And if I have I don't know, I have a purchase endpoint and I don't have enough credit, then I will return this 403 forbidden, and then the error type will look exactly like this. So do you have for every error a specific error type that usually then enter to this form?
I think the usual situation is that you have one or two success cases that usually use your schema that where you return the useful information from your endpoint, and then usually for the different error cases you can use just one reused structure, because it should be enough. For errors you usually don't return as so deep detailed structure. That's why actually it's possible to use something that's like a worldwide standard. And also for the security reasons, you shouldn't expose too much in the error case, because that's what the hackers try all the time, to reach some error states and learn something from it. So and in your Open API specification, you can directly refer to that standard. You don't even have to include it in your open API, but you can, if it doesn't change, then it's not like a big difference if it's inside your open API or if you use a reference to an external document. Yes.
So you mentioned API version. What do you prefer? Is that URL head versioning or header versioning, or that depends on project?
Me personally, I like using headers more because it doesn't break your resource structure. As I said, URL should be an identifier, and actually, there's one more thing that I should have mentioned. When you have a breaking change, you should think, is it still actually the same resource from the business perspective? Because many times it is caused by some feature change that makes the structure obsolete, and in some cases it's actually a different thing that you are returning or expecting. So in many cases it might make sense to actually just name the new resource properly according to its new business meaning, and then you don't need to think if it's V1 or V2. So if it's still the same thing from the business perspective, I would go for keeping the same URL and handling the versioning in headers. And if it has a different business meaning, then you can add a new endpoint or new resource. And there's one more thing maybe that I can show you. I like to integrate not just using APIs. I also like to connect people and communities. And one such thing is I'm trying to tell Java developers how Kotlin can be useful to them. So that's a free ebook that you can get from me about that. But yeah, so connecting can have many forms.
Okay, last question. Well, then thanks a lot.
Thank you too.
Yeah, in like 6 minutes we will continue with the next talk.